So good morning, everyone. Good to see you all here at NDC. Of course, a bit different, but happy to see you all sitting in the room. Hi, everyone. The other side of the camera. So in the next hour, I'm going to take you through a problem which is all about software supply chain and about the security of software supply chains. First, it's always polite to introduce yourself, like who are you? And I do it always, but like a picture, like that looks really big if you see it on screen. But so my name is Niels Tanis. I work as a security researcher for Vericode, and I've got a background in .NET development. I started out developing with the first .NET bits in the early days, so like 1.0. Always was like interested in application security, so not only authentication, authorization, but also vulnerabilities that we're facing, SQL injection, cross-site scripting, and so on, right? And I've done development for quite a while. Then I moved into the security space fully. I've done some ethical hacking, pen testing, which is a lot of fun. It's like solving puzzles with a big team, breaking into computers, and even getting paid for it. Like, hey, that's a good combination. But then I realized, like, hey, I'm missing out on something. I really like using new technology. I really like to build software. So then I was able to join Vericode 2015, and in 2016 I joined the research team, where I'm mostly focused on what we do for static analysis for .NET applications, right? So analyzing applications for security problems and security issues. My day job is just to program the heck out of every SDK and to see what could possibly go wrong, and then hopefully help out our customers doing a better job. So that's enough said about Vericode about me. If you want to talk more about Vericode, come see me afterwards or drop me a message on Slack, because we're going to talk about the .NET application software supply chain and its security. Right? If we look at the way that I started out my own development, as I said, with the early bits of .NET, you would most of the time just create an installer, and you almost like walk over physically to the IT guy to say like, hey, install this one on your machine or on one of the systems that's available for all your employees, and then you're good to go. And if you see the shape that software is in right now, with all the things that we do with cloud native, continuous integration, software's being deployed in a matter of minutes, even seconds maybe, but quite continuously, right? There's no real, like, I'm just handing you this install, do it. Right now, it's more of an ecosystem, and there's a lot of moving parts. And that makes it complex, right? And what Mikko said in his keynote, if some stuff becomes more complex, there's a lot more security risk. And that's exactly what also happens with systems itself, but also the processes we need to do in order to build our software and release it. So that's in general what I'm going to talk about. So I don't know if you have seen talks of me about supply chains in the past. You're probably going to recognize some of the stuff I'm showing, because concepts do not change, right? It's all still the same. There is some really good movement in the space done by the big companies like Google, like IBM, Microsoft, where they show us a path forward on dealing with these issues. So you will see concepts that are the same. I'm probably going to use analogies that are the same, but I have a couple of demos which are like spot on, even stuff that was released last week, in combination with, of course, some cool hacks we need to talk about, because that's always fun to see that. So just a matter of abstract agenda, we're going to talk about supply chain. What is it? Then I want to focus more on its threat model and securing the software supply chain as a whole. We need to look at how developer interacts with source and how he uses source code, right? That involves your IDE, that involves authentication on source repos and so on. Then we need to focus on third-party libraries, because a big chunk of what we do rely on things that are developed by others. I'm lazy, you want to reuse, so why would you not pick something that was already created by somebody else? And then we're going to focus on build and release. And then at the end, we will talk through a couple of examples how stuff is being fixed. And then conclusion and Q&A. So we're going to see how it works. If you have questions, please drop them in the Slack channel of this room. I will take a peek on my phone at the end if I want to have questions, and I can see if I can answer them. One thing I always like show, and that's also what I said about the monolithic app versus the stuff that we're doing right now. If we look at software and how it has evolved, we moved from the single box that contained it all to smaller bits and pieces that were deployed across literally cloud infrastructure, right? Cloud native stuff. So becoming a monolithic, moving to server orientation, as I did with SOAP and XML, which was highly bloated, right? Big messages and so on. Then luckily, technology got a lot better. By using, let's say, gRPC, JSON, like much more minimal communication, and that allowed us to do better services, better service orientation. And of course, stuff like serverless, Azure functions, Lambdas, you name it, right? But it's all becoming smaller chunks. And in order to release something, the way that we deal with that, of course, as I said, becomes a lot more complex. But if we then look at the supply chain, what is a supply chain? And this is the analogy I always use. Car manufacturing. If we look at how a car gets built in a factory plant, then at some point there's a lump of steel starting out in one corner of the factory, becomes a chassis, And during out its stages inside of the factory, value will be added, parts will be added. On average, like a German car manufacturer will have 10,000 parts on a car. And those 10,000 parts, and there comes the problem, originate from 2,700 different suppliers. So keep that in mind, right? So the disc brakes might be made by somebody else compared to the exhaust. It's all being put on the car, and at the end, the product will roll out the factory for that customer. And that whole chain from lump of steel to the end of car, that's a supply chain. And if we then look at software supply chain, of course, we can probably draw this picture. And this is an abstract picture of a supply chain that I'm going to use throughout this talk, which I'm going to focus on different areas and different risks, as I said in the agenda. Right? But it normally is a developer that interacts with the source system. There's a build, GitHub Actions that does stuff for you on commits, on tags, whatever. We have third-party libraries and registries and artifacts, repositories that we get our stuff from, that we build. I'm assuming we all do Q&A compared to, let's say, testing, security testing, really important, of course, if you work for a security company. And then at the end, we have a deliverable that's being pushed out to, let's say, GitHub artifacts, which might be a Docker or a package that you share with your consumers, and so on, right? And it might be even resulting in something getting deployed on the Kubernetes cluster. And then it gets run, and everybody has it available. So this is a software supply chain. This is the thing I'm going to talk about. And I'm focusing on software bits and pieces and the things that developers do. If you want to know more about hardware, network, infrastructure, then you should see the other talk that I gave. There's a couple of examples on that. Because if we then look at software supply chains as a whole, like what could possibly go wrong? And there's one company who has been in the spotlights for this, and it was a really big thing that happened, right? So that was the supply chain attack against SolarWinds. SolarWinds creates monitoring software that gets installed across an organization to look out on systems, like to monitor them, to do some metrics, I believe. And their build system, one of their VMs, or a couple of their VMs in their TeamCity environment, I believe, got hacked. And got hacked in such a way that each build would add an additional DLL assembly into the output. I believe it's all .NET what they're doing. So the DLL got put in, and then it got released throughout the customers. And with that supply chain, right, with that whole build system, and the adversary was able to inject something, and I believe like it was like used as a backdoor. And keep in mind, like, because security has been talked about a lot, also from infrastructure perspective, hopefully organizations have locked down all the access that they have, right? That's step one. It's always infrastructure, and then application layer 7 comes next, and that's exactly what you see here. So aside from the fact, like, what are the motivations behind who does this? Is it a nation? Is it something else? These types of software run on a highly integrated basis within a company's infrastructure. So if you want to hack something and have a big footprint, then you focus on this. And that's exactly what happened. SolarWinds is also the company I'm going to get at the end, because they fixed this problem in a real cool way, and that they published, I think it was over summer, at Supply Chain Security Con, if I got the acronym right, or the name. It's part of KubeCon, it was held in the US. They showed the way that they fixed this problem, and it's really cool. And I think it opens up doors for others to do exactly the same, because this is just a hard problem. Another supply chain problem, or are we allowed to call it a supply chain problem, software supply chain problem, is something that happened with Kaseya. Right? So Kaseya is software that's used by managed service providers to do infrastructure maintenance, software maintenance within companies. And once again, a piece of software that's highly integrated into organizations, right? But is it really a software supply chain that got compromised, right? Because it turned out that the software itself had a SQL injection vulnerability inside of it, which allowed attackers to compromise some running instances of Kaseya that were used by the managed service providers, right? So like a software as a service solution. And then they were able to do the ransomware attack on all the different customers of that managed service provider. So technically you could say, like, hey, did the software supply chain really get compromised? It's more like a supply chain, right? Because it's a tool that's used to manage their infrastructure. And yeah, that's up for discussion. So this is a blog post from Sonatype. Look through it. I think it's disputable. Right? Still, it's a big problem. And as I said, because it's infrastructure, they will focus on that. And then I always need to show this cartoon because I think it's really funny. You probably are aware of XKDC. They have like the SQL injection Jimmy drop tables, right? This is one that's related to dependencies, and they call it the modern infrastructure. But you can just replace it with software. So you have a stack of stuff you build on top of each other, but then underneath there's that single piece that's thankfully maintained by somebody in Nebraska since 2003, right? And I think to some degree, a lot of software projects rely on people that do open source and they do the best they can. But that's the risk that you're facing because everybody builds on top of it. And if one of those bricks comes out, then it will collapse, right? So this is always a funny thing to look at. Enough said. Let's move to first step, developer, source. The red arrow in this diagram. What could possibly go wrong with source and source access? If you use credentials, credentials get stolen. And in 2019, this was 2019, I believe, the canonical GitHub account got hacked. And it was just an ordinary credential theft. So username, password got stolen some way. And somebody created some malicious repos. I think not much happened. At the time of writing of this article, they say like there was no indication of compromise of canonicals, like Ubuntu source code. And Ubuntu is, of course, the distribution. If you look up my demos, and I'm showing later, like the build pipelines, it all runs Ubuntu, right? So you can see, like, this is probably a target. Turns out that this probably could have been circumvented with maybe an additional factor, right? If you use a source repo online on GitHub, I'm assuming you all use multi-factor authentication with something that might be even like a YubiKey that you can use for this purpose, or multi-factor authentication with Google, with the Microsoft Authenticator, right? The additional factor would have helped out mitigating the risk of credentials getting stolen and misused. And if we then look at what Git can provide you more, is something called GIT Commit Signing. If you work with a Git system, you can also associate a PGP key with the things that you're doing. That's a public-private key pair, so you will sign the work that you're committing to the source repo with your private key. And then you can validate it with the public key you share across your peers, saying like, hey, this was really me. But this is the additional factor, right? Even if all the other credential stuff got stolen, you can still say, hey, if that verify box doesn't show up, then that is a strong indication that something got committed in a way that it's not supposed to be committed, right? This is only a visual indicator. People say like, this is not the right thing, but I like from first step, it shows people that something happened, and it allows them to investigate further, right? And you're probably going to see out with the supply chain problems I'm facing, like it's not going to be like a silver bullet. We're going to put something on it and then it's done. No, we need to rely on data, we need to see, and we need to make decisions based on stuff that we see. But I would encourage everybody to use this, to sign stuff, and to have your project configured that the contributors can maybe only push stuff that is commit signed or tags that are signed in their repos in order to do their work. Then if we put it all aside, this is all authentication, right? What else could possibly go wrong? And that's something that University of Minnesota spent some time on. This is a thesis that somebody wrote. What they did is maybe pretty annoying for the people who are involved, but they investigated. They became part, I think, like of some part of the Linux kernel, and at some point they were contributors, and they decided to do something malicious with their contribution, so add some malicious code to the kernel. They, of course, got banned by the others, which were quite annoying, but still, if somebody has big means on getting somewhere and wants to get into things, then this is still humans that do work, right? And they do the best they can. But this is still a possibility. And similarly, with a library called Event Stream, which was an NPM package, somebody just participated, and it all looked good. But at some point, he decided to do differently, right? And the only way that you can deal with that is still have mutual reviews. If you're working on a piece of code that's critical to the software that you're writing, because it's all based on risks, right? If you want to secure software, you can put stamps on everything, but it doesn't help you. You want to focus on the risks that matter for you or your organization. Then you should still always make sure that critical code gets reviewed. More eyes look at it and say hey, this is wrong, this is not good, we should not do it. If we interact with source, what else do we need? An IDE. And this is just a small side step, but I think it was it was May, right? May 2020. The GitHub security team published a malware attack that was targeted against the NetBeans IDE. NetBeans allows you to do Java development. Turned out that every artifact that it built, it put additional things in it. Well, this is quite a sophisticated attack. Why would somebody do that? Somebody had different means. Why would somebody focusing on an IDE that's used for development, and why not focus on build systems and have them compromised, because that's a lot of foothold in that space and less on IDE. So who's done it? They don't know. I'm sure I haven't read about anything that was clear this was the reason, but people do this, right? And similarly with the IDEs I'm using, I'm spending a lot of time in VS Code. And if you look up VS Code runs on Electron. This is a NPM dependency graph of Electron. which you see over here. And it's a big one. There's a lot of information that you can probably not read it, but it gives you some perspective. So keep in mind that dependencies trees usually have transitive dependencies, meaning you pull in one package, you probably get 5 for free after it that will be pulled in for that same reason, because it's needed, right? If we then look at this Electron dependency tree, which is used by VS Code, but it also runs on Slack, right? So it's all the same. There are in total 110 maintainers on these projects that end up in Electron. And those are only the maintainers. Those are the people that are responsible for releasing those libraries and that will like maybe even put the time into it, fixing it. There's even more contributors, of course. More people touching that code. That code base ends up in your VS Code that you use to develop, right? So, and stuff will have vulnerabilities, and that's exactly what VS Code has. So this is a report that was of November of this, beginning of November this year. A privilege escalation bug inside of how it parsed specific files within VS Code. So this, of course, forces the need for you to keep an eye out on your IDE and update it. And I love VS Code because the whole extension system just works. If I need to do something in a language I haven't worked with a lot, you just go to VS Code, you get the extension, you just work with it, right? It's nice, it's vibrant, it's a good ecosystem. But this is the risk. And there's even, of course, still people who are involved, like building it also. And in January of this year, a researcher stumbled across a problem which turned out to be an issue in the issue system of VS Code, which allowed them to have push access to the main repo. And he could just alter the code that ended up in VS Code by just, I think there was a CI script, a YAML file that didn't parse properly, some variable that was given to it, and he was able to get a push access. And he got a bug bounty out of that. People make a lot of money out of this. Because, yeah, it's good to report it and then it gets fixed, right? We all benefit from it. So, enough said about software, about code, interaction with code. Next up would be, let's focus on libraries, right? So, as I said myself, if I develop, I preferably use stuff that's already there because I know that people have solved problems that I might face if I'm doing it myself. And that's a good thing, but also you need to be aware of the stuff that you're doing inside, right? You need to have some sense of what the library does. So each year at Veracode, we publish a report, and this is the only time I'm going to mention Veracode once, then it's done. We have a report which is called State of Software Security, where we take some of our metrics of our service, because our analysis service is a SaaS, so we have some metrics of stuff that we see happening. We concluded this year that almost 80% of the time dependencies get added to a project and we don't see them change after that, which is quite disturbing because dependencies, of course, have issues. And what could possibly go wrong with dependencies? Dependencies have vulnerabilities, right? So this is an advisory that was given out in October of this year related to .NET Core and some LDAP things that was like plain text on certain conditions, right? Maybe, I'm not sure like how big the problem is, but this is still a reason for you to update stuff once you're like developing and once you have your system in production. You need to be aware of what's inside. We're going to touch a lot of that more after this. Second, libraries have vulnerabilities, right? That's first. What else could happen with libraries if they're used a lot? People will inject malware into libraries because they want to do something with cryptocurrencies, not crypto, but cryptocurrencies, to make money. Right? Because that's a means of doing it. So this is something that happened to a parser package that was in the NPN system, which only helped out with parsing user agent strings, which was, I think, an average download of 1 million a week or something. Turned out that the maintainer of this package on NPM didn't have multi-factor authentication, and it was just an ordinary credential theft that happened that allowed somebody to put malicious code in it. So everybody relies on that single brick in that drawing you saw earlier, right, underneath. This is what happened. Luckily, GitHub did act on this, and I think this is a real good thing. They said, like, yeah, we force maintainers to use multi-factor authentication on NPM, right, because that reduces the risk of these kinds of things happening. And we're also going to look into packages and see if there's any malicious intent inside of those packages, right? So that's a good step forward. But if it's an ecosystem that's used by a lot, then these things happen, right? Similarly to something that was published in February of this year, it's called Dependency Confusion. So this is somebody who also does a lot of bug bounties. And what he figured out is, like, if we use a package repo, a package on NuGet has got an identifier, right? A name. You say .NET add package, you give a name, and that name will then like be resolved, and you get a package back, and it will be installed on the project, or it will be used by the project. You also might have got like private repos internally to the organization, or artifact repositories where you fetch libraries yourself with names that are not supposed to be public. And that's exactly what dependency confusion is about. So let's say if I figured out that an organization internally uses a specific name on a package that's essential across their infrastructure, and I can maybe publish a public package with the same name, then that might confuse the resolving, and I get that other version in. And that's exactly what he pointed out, which allowed him to hack a lot of companies, and this guy made a lot of money out of it because of the bug bounties tied to it. Right? So it's a pretty basic thing if you think about it, but this is like if you pull in dependencies and you rely on an external system, then you need to be at least aware of it, right? What can we do within our new NuGet ecosystem? I think that's the thing I want you to take away, because I can talk about stuff that can go wrong and what you need to be scared about. But in my slides, I have notes, and these notes contain links, and you can find the slides on the GitHub repo I'm going to mention at the end, so you need to stick around for that. But you will see that there's a white paper of Microsoft where they point out on the best practices in relation to packages management as a whole, and they also have some key things for NuGet. And if you're like really paranoid, you should maybe focus on doing a single private repository that's only internal to your organization. If you work for a big company and they run application security, I can probably imagine that's the case. Security team wants to have control over which dependencies are run where, right? Because that poses a big risk, as you have seen earlier. And if you then look at, let's say, what Azure can help you out with, you can do with Azure Artifacts, I believe you can do also like upstream resolving of packages, of external packages, right? So there's a lot of control in that. That helps out getting control. If your company has public packages with the same identifier, or if there is a name you're like keen on getting to, there is a process of getting that prefix registered within NuGet that nobody else can use it, right? So that might be an opportunity. Let's say your company has some public packages that they share with the community, but internally you also have packages that have same names, but only on internal, then it would make sense to do that, because that limits somebody else using that identifier within the package, and that might result in dependency confusion. You can also do a poor man's approach by taking an identifier that belongs to a company that you do not own, but then make a unique name that's probably not guessable, and then at least have some security, right? I'm not saying that's the right thing to do, but it's an opportunity. And of course, with package management as a whole, you can do log files with NuGet, right? And that's probably a maze, and it's not like version like A and B, I want to have that. But if you're really keen on having control over what's pulled inside, then that's the alternative, making sure you lock down the dependencies that you use. So as I said, all the links and all the things that I talk about are all inside the notes of the slides in the PDF form, in the PDF file. If we look at dependency confusion, and this is a small sidestep, there's a lot of other things also similarly happening, right? So WordPress had a thing published, I think it was November, it was last week, and I ran into this as like, oh, I need to add this on my slides because I think this is funny to see like how that evolves. If you run a WordPress site, same problem. Private plugins that are internally can be overridden by ones that are publicly published. And that's exactly what this guy done, guy or girl, done it. And he also made money out of it. It's like, just laying around up for grabs. But it's funny to see that these concepts evolve, right? And it's inherently to software development and the way that we do it. So confusion, it's a big problem, and we need to have at least some control over what we consume from what point on. And we also have an aspect in that on building stuff, which I'm going to mention later. Now, a bit more on third-party libraries. I said it at the beginning, I was talking in the back of the room saying like, hey, if you consume a library, you always need to know what the intent is of the library. Why are you using it? What's the goal? What do you want to achieve with it? You need to know to a certain degree like what's inside. And as I said, you pull in one dependency, but you always get a tree of additional stuff underneath it, which is a lot bigger. So I did a talk on sandboxing .NET assemblies last month, which is not published, but you should keep an eye out, where I talk about a concept within .NET that allows you to sandbox these things and take out privileges like rights of components, because I think there's a key to that. Similarly, like WebAssembly, new technology has a concept called nanoprocess, and they exactly do that for this reason, because you don't want to rely on a third-party package, but also not on the future versions of that package to be the right one. and to have the things inside you expect, right? That's the thing. The Open Source Security Foundation, or the OpenSSF, which is part of the Linux Foundation, has also started out some projects on security. And one cool thing is something called security scorecards, which is a security health metrics of open source. Because also supply chain things, Microsoft is going to say the same, we need to secure the open source system because there's so much code coming from that space that's used by everybody, right? That's the biggest win. So what we can achieve with security scorecards is some kind of a metrics. See it as a nutrition label on something you grab from the shelf. Look inside, you see what's inside. You see like, hey, this is a lot of salt, maybe I should not eat this, or too much sugar, right? That's also a thing you don't want. So this gives you some metric, and Scorecard has a calculation, and it will show you some of the metrics. And this is a methodology that they support. And Google has done a project which is called DevSDEP. And if you go to that site, they will allow you to understand dependencies, right? Understand what's inside, understand its intent. I think this is cool. So they're not supporting NuGet. I think coming soon, I've seen that for the last 6 months. I'm hoping that it's released soon, that they also support NuGet. But if you then open up a package as Electron in NPM, I'm not sure if you can see this, but there is a secure card section where it shows like, hey, this project doesn't have any branch protection in its source repo, so that might be a problem from security perspective. They also do not sign their releases with certificates, or like authenticates, like signing your package, saying like, hey, there is some authenticity to this package, right? No guarantee what's inside, but the authenticity, like somebody created it at that point with that certificate, so it should be fine, right? That's the thing. So I think this is cool, and there's a list of projects that consume this data that have this. So look into the website that I mentioned before. If you search for security scorecard, Google, you'll find it, and devs.dev is also there. So a good step forward, right? Giving people the information to decide for themselves what they need to do. If we then look at third-party libraries, what else could go wrong? And since the release of .NET 5, there is a concept called source generators. And there was even, I believe, a talk on the first day, which was really good on NDC, about source generators and how you can use them. But with that source generators also comes a backside. So this is a blog post that's been written by a colleague and a friend of mine, Matt, also from the research team from Veracode. And he talks about source generators being used to do supply chain attacks. So a source generator can literally sit in everywhere. If you have a third-party library that needs to be doing something at compile time, right? It might make sense to have a source generator inside of it to help out to generate some stubs in order to use it. But with that, it also comes the possibility to have some malicious stuff being generated. And it's not always as visible that happens, right? Because they're based on Roslyn, right? So they will just add stuff to the tree. So you don't see any files. Those compiled artifacts will just be added. So there is a venue to that. And he has an example where he shows ASP.NET Core also has one piece where it resolves like controllers based on name, right? Which will be replaced by a source generator, because that's totally making sense if you do that at compile time and saying these are the controllers. Then you can see which controllers are exposed to the outside world. But here's a nice example where he talks about this. So the blog post is in our website, the link is in the notes. What can we do about this? This is like a thorough countermeasure. Just disable all analyzers within your project. And this is probably not what you want, but I think it's good to have sense of which project need to run source generators and we need to have access to that feature because of this, right? So considering doing that at that level. So let's see, we're in halfway. Now we're going to talk about builds. We're going to talk about reproducibility, and we're getting close to the first demo. I got a couple of demos I want to show you. The key for software security and supply chain is a thing called reproducible builds. And what I mean by that is that you should be able to get up to a source repo of a library that you're using, get its source code, compile it, and you should be able to compare it to the package you get from that package manager, for example. And that's something they call reproducible or deterministic build. So source code results in same binary, and every bit should be the same, because otherwise I have no guarantee that exactly the things that are like being input in code are really inside that DLL, right? That's the thing. It's a hard problem to solve because there's a lot of moving parts. If we look at .NET itself, as from Roslyn 1.1, it started to support some kind of deterministic behavior based on inputs. So given the same inputs on a machine, you should expect to have the same outcome. So output should always be deterministic. So if you look at a list that's inside of the Roslyn documentation, you will find a list of deterministic inputs. But that's not only like file system, but it's also like which SDKs are installed. Like there's a lot of things on your build system that will influence, or that will possibly influence, the way eventually something gets emitted into an EL representation inside an assembly, right? So that's the thing to be aware of. This is the default reproducibility, how it does it right now. That's been the default for .NET Core. So it should help us out. But then now we're going to do a game, and we're going to see like if we have if we have an app in .NET Core 6, how reproducible can we be, right? So now I'm going to end my slideshow. And make sure you see my screen. Hold on a second, this is my desktop. So I'm assuming everybody is able to see the VS Code. So this is a really fancy console app, right? And this is of course one of the new features, like a single line results in an application, and it's a console app. Just a .NET new console, this is it, right? So we can build it. We can say, okay, .NET build app, and we're gonna build this, and we're good to go, right? But let's say we're going to copy this project and call it app 2. And then we're going to say .NET build app 1, again, for just to be sure, app, and build app 2. You would expect, the first question, what would you expect? Do you think that these DLLs are exactly the same? There's only one way to find out. So what I'm doing here is just an ordinary diff on binary level of a DLL within a Mac. And if we look at it from binary level, same project, copied, right? So, but the project file is the same. The inside code is the same. They do differ. So why is that? So of course we compile, but there's a lot more things, right? So if we look at strings representation of those files, we can see a lot more. So I created a script over here. I'm just going to show you the contents a bit. I'm going to put out all string representations in this DLL and compare those with each other, because there's the essence of what's different within these DLLs. So that's a tip of the thing. And then I'm going to diff these inside of VS Code for our presentation. Hold on a second. So it's doing that, starting out, looking at. So these are the string representations of that code. And what we see here is, of course, if you've worked with this, you probably know this, like there's a reference to debug symbols. And these debug symbols have a different path. And that makes these DLLs different. But internally, those compiled representation of that console write line is exactly the same. Right? So the debug information screws it all up. We can do one thing by saying like, hey, there's two possible ways. You can rewrite the PDB path saying like it's relatively and standing somewhere there. I'm not sure if that's what you want. If you do a package, we will get to that in a minute. But let's say now for demo purposes, let's do the following. Let's just fully not emit any debug symbols. And let's do a clean. And let's say I'm copying the app again. And then let's do the diff again. It should be. And now we see it's all green, and those are exactly the same. So the string representation, so the things that were inside, is exactly the same because we just pulled out the PDB location that's in the PE header somewhere, right? This is of course not a way to do reproducibility. If we do software development in such a way, we should focus on getting builds really deterministic. And how can we do that, right? So it's not even as trivial. Even if you have project locally, right, there's still a bit of a difference. If you look into, let's say if you would decompile the IL and look into it, then it's probably the same. My machine, right, it's the same machine. So the things that I talked about with Roslyn and deterministic stuff, my SDKs that I've installed will be the same for those things, right? So What should we do then with real-life projects and not with some stupid console app that does a console write line? There is a package called .NET Reproducible, and that thing allows you to do a lot of these things in a good way. First of all, it will make sure that all the debug symbols are embedded, and it will also put a flag on continuous integration build, which will indicate for the build server, like, hey, I need to make sure that the paths are being resolved in such a way that it will be the same. And it also introduced something called source link, right? So if you have a package that you publish and you have a repo, then if you want to help out the developers and also being able to use the package and debug into it, source link is your friend, right? You will have that. If you have the package included, it will set all those properties, and then you will be deterministic. And even if you look into the package itself, you will see some flags being set, like, hey, this is a deterministic build. We have source link available, which is all good. That helps out the people to reproduce that package. That's a cool thing. The next step is something that's called hermetic builds, and that's the next thing. I mentioned to you that Roslyn relies on SDKs and stuff installed in your system, but hypothetically speaking, you want to have no dependency on the system it runs on, whatever, right? And that's something that hermetic builds supports. There's another additional package called reproducible.isolated, which is coming from the same project, and that also locks down the folders that are used to resolve packages. That will give you more control of where stuff comes from. And it's probably not going to result into a full hermetic build, but it will give you more control. I think that's a good step forward. If we look at the other world, there is a build system called Bazel, if you're interested in it, that's being used by a lot of cryptocurrency projects. And Bazel allows you to be reproducible and hermetic in build systems. And they've done a really good job up front. You can just grab their source, and what they do if they release, I think one of the projects, they will get one project built by someone, and somebody else also built the same project, and they only release if those two match. And that's key. That's the key, right? Doing it twice, looking into it, and say, like, this needs to be exactly the same. That's going to solve a lot of our problems. We see it at the end of this presentation. So hermetic builds. I think this is a good step forward. So reproducibility. We saw the security scorecards also mentioning something called signing artifacts. And this is, I think, a really cool project that's been started out. I think it's also the Linux Foundation, Open Source Foundation. Sigstore wants to be the Let's script of software signing with certificates. And so they have a root CA available for everybody to use. And you can just grab a certificate pretty easily and sign your package with it. Right? So you can have some authenticity. And as I said before, a signed package doesn't mean that it's secure, but it will give you some sense of its origin. And if you tie in everything in the right way, from beginning to end, it even gives you a nice trail of where stuff happens, right? And that's in essence what we're facing with supply chains and with their problems. So Sigstore, you can read about it. There's like, how does it work? But there is like a root CA, there's a transparency log, right? So every certificate that gets generated will be pushed into a transparency log, similarly to what Let's script and what all the others are doing. So you can see that that certificate was generated and everybody can validate against that. And they also create tools around it. So Sigstore itself is not something, but the tools that are built on top of it are really valuable. And one of them is called cosign. And cosign allows you to sign Docker images, containers. And cosign can even do keyless signing, and now it gets really cool. So you can, of course, just use cosign and have keys generated locally, right? If you do Let's script and you have that bot running, you need to generate key files locally, and that will then be signed. And there's a lot of processes, steps happening in between before that's done. You can do similar with cosign, but the other thing that cosign supports is something called keyless. And what they do, it's based on OpenID Connect. So if you do cosign, and there's a lot of demos you can find on the internet if you go to their website, you will see that they are able to sign a container. And once somebody starts it, then there will be a browser pop-up, and they say, please log into Google, Microsoft, or something else. And then their identity will be fetched, right? OpenID Connect. And that will then be the subject of the certificate where the package will be signed with. And that's in key, I think, the reason why this works. Because then you give the consumers of your package the guarantee that somebody who signed this package owned that identity and owned that hopefully well-secured multi-factor authentication, username, password type of thing on either Microsoft or Google, right? It gives you some guarantee. That's cool. The other thing, GitHub Actions also supports OpenID Connect in the Actions context, meaning that it can go to another server, authenticate itself, and do stuff on their actions. And this is something, I think it went GA last week within GitHub Actions. And it's really cool, it allows you to do. One other thing is that, funny thing about co-signed certificates, the validity of those certificates are not 3 years, but 30 minutes. And you're like, hey, how is that going to work? But 30 minutes is exactly the time window you need to sign a package. It will be timestamped, so once that certificate has expired, it's useless for others to use. But the signature is still valid, because it was signed at the moment when the certificate was valid, right? So I think that's a really cool concept, and it works. So what I've done is a demo, and I'm not going to run it because of the time. But I run. I've got like there's another repo. I've got one repo with the slides and with some of the demos, and this is a web app repo that has a couple of build integrations I want to show you. So there is a. Let's do this differently. Let's go to it locally and open up the file. I cannot see. I have no connectivity, I think. Should have checked that. I'm sorry. Let's go to the web app and let's say code in this space, please. Then we can hopefully see the YAML I can talk you through, which is enough. GitHub. And then you always get bugged with dialogues. Let me just bear with me for a second. So there's a release one. This is the one I'm talking about. And there's a lot of things in, but you can go. This is a public repo. So what it does, it's you can see. I shouldn't have mentioned anything about not being able to get into it. Hold on a second. So I'm not sure what's happening with the cable here and with the internet, but this is the one I was planning on showing. Is it working or? Yes. No, this one, but I have no connectivity. So I was in VS Code, which is the YAML file I was planning on showing you online. So, and we need to just deal with this in this way. So what you see over here is that you can have identity tokens available, ID tokens available within GitHub. This is the new feature. And what we then see at the end is there is a cosign package that I set from Sigstore, and that will then sign the package. It will push it to a GitHub artifact repository. That's what's happening here. You can check it. And then it will do a verify, and then you will see that the certificate will have the identity of that build pipeline that gets executed. And that's exactly, I think, what you want, because that gives the guarantee, like somebody opens up the package, then goes to the repo and see that the action has run at that point based on that tag that's released. So there's some authenticity between the fact, like, hey, build has run, package is there, and it has been signed by the GitHub action. So that gives you guarantee from that step, right? It's unfortunate that I cannot like access the other ones. Let me see if we can get around this. Because aside from signing artifacts, as I said, doesn't give you any guarantee. And all the problems that I talked about are already pinpointing solutions in the whole chain of that diagram I showed at the beginning, developer, source, and so on. How can we have source to binary guarantee of something being the right thing? Then I'm ending up with the automotive industry. One example again. If you have a car that has parts, which has been taken apart here, which they then always did, like in a car magazine I was reading, 100,000 kilometers, and then get it apart, see how much it has been worn and torn. Parts are being produced based on the supply chain thing, right? So as I said, iron ore is needed to create disc brakes, end up in a car. Let's say at some point they realized that a batch of steel wasn't the right quality, and the disc brakes made out of it contain like hazardous stuff. So therefore we need to recall all the cars, right? You probably have been in that situation where you got like an email or a call from your dealership saying like, hey, please bring back your car. We need to replace the seatbelt thing, or we need to do something with your brakes, right? That's a whole ledger of stuff. They know which part of which supplier ends up in your car, right? That's the thing you see on the right. And I think for software we need to do exactly the same with a concept called software bill of materials. So it allows you to describe software, like who created it, what's inside, has it been altered? I think that's the key thing. How can it be used? What type of materials are being used to create this? This is the theoretically example of software bill of materials. There's a website of the NTIA.gov in the US. They have a real good like articles on its definition, what they think is the right thing. It's still something it's a dynamic process, you will see. Because I think if you want to do one thing right now from the start, I think it would be good to have some kind of SBOM related to the dependencies that you're using inside of all your projects. And CycloneDX is a project that originated from OWASP's dependency checker and is there for free. You can use a lot of stacks, but you can create an SBOM, a lightweight SBOM, that's how they call it, which is like a full transitive dependency tree of your app. And if you then do that at build time and also store that file and correlate that with that build, that's step one, because you know what's inside, you can deal with it, and if there's a vulnerability published, then you can act on that, right? InTodo is a tool that does exactly the same, and I'm just going to skip a bit of this because it's for the time's sake. But InTodo demo, I gave it in my other talk. You will see you can have source code and binaries, and you can describe the supply chain, saying like stuff gets built. I expect the files from the build to be used inside the binary that results in these binaries. These sets of binaries will then be packaged, and that package will then be published. And those steps are all signed by people with public-private key pairs, and you can check it with the public keys. That's a demo that I've done in the past. And then you will see that, hey, if something is altered, then that's a tripwire. Then it will alert you, say like, hey, this file has been altered in this step. Is that supposed to happen? That's an indication of something happening, right? So InTodo has a lot of terminology around it, but it allows you to describe that whole chain and allows you to verify it, right? And as I said, the demo is maybe a bit too much for now, but it's in that same GitHub repo. You see that there's a build. I can quickly show you the YAML file. Let's do that. That's better. And you can see a run after it. So the CI thing over here, what it does, it installs InTodo. You see that this is quite a tedious process, and I'm going to get to it why once I'm done with talking you through. You need to record steps, right? So InTodo has the ability to say like, hey, I'm doing this step. I'm producing materials that comes from the compilation. Then I'm doing a publish, and then I'm expecting these products to be in, and those are all signs. I'm doing a CycloneDX step here, which produces a JSON file that I'm also signing in the same supply chain, knowing that this artifact was created at this point in my build. Then I'm doing a pipeline scan, which is like putting it to our servers and doing static analysis. And then I'm also like, these are the signing of those files, saying like, hey, these files are created right here at this moment and signed by the build server. So that part is then covered. Then I package it up, and if you grab this file, you can get the link files and you can verify its in contents. You can say like, hey, this step has not been done. But unfortunately, I cannot access those files right now, and I haven't got them locally. This is stupid. I'm sorry. You need to get back to that one later on. But the whole purpose of those artifacts allow you to validate, right? It doesn't solve the problem, but it allows you to take action. And as I said at the beginning, we talked about SolarWinds, and I'm going to spend my last 10 minutes on SolarWinds because I think they are really in a good space on how they fixed that problem of their build server and getting compromised. So at the Supply Chain Security Con, they published a project called Project Trebuchet, which stands, of course, for something else, but you will get it once I show you the next slide. But they decided to have a CI/CD system based on Tecton, which is an open source like native CI. It runs on Kubernetes. It can do CI/CD for you. And let's say, for example, IBM's OpenShift is also based on that. Tecton can do YAML. It can do like descriptive files. And then they had some integrations done with GitHub, so the developers are not bothered with it. So they push source changes to it. Then Tecton will build it. Tecton Chains is an attestation controller. And what I'm doing with my demo, which unfortunately didn't run, but every step I need to administer the things that have been done. Tecton Chains has the ability to do that by default, and it will sign those steps for you. It will produce those artifacts without you even thinking about it. So that's really cool. And what they also do is they put it in a database and having it centralized, available to do decision making. Because the demo that I gave, like that I have running, is like grabbing multiple files from different locations, and how could you like even correlate that data? That's too difficult. That's not going to work for nobody. That's not a solution. This is. So they have attestations from source to binaries, and the binaries are, I think, they do binaries in S3, and they push out images to Amazon's container registry, I believe. How can you then validate this easily? By creating a second instance. There's that second instance I mentioned before, next to it. And what they do with that is that that's a more highly controlled environment, accessible by less people. But what they do is they rerun exactly the same build on that highly controlled environment, and they expect it to have the same artifacts published. So you can cross-check it, right? And if you then have policy checks, and if you can query that data easily, you can easily see like, hey, something happened in that step that I'm not like happy about because I don't know the outcome, and it's different in the way that we run it in the second time. So we need to investigate that before we release. Right, and that's I think in key a really good solution. Similarly to what we have seen with that Basel cryptocurrency thing I mentioned, right? Having that second thing available for you to verify it and not have any burden of dealing with data. Of course, it still relies on your ability to write policy checks on that data, right? It's hard. And Tekton, I think, is really in a good space because this was an article that was published in September of this year by somebody from IBM, and they show exactly the same solution as SolarWinds is using for building their container images and their microservices. So it's a nice blog post. As I said, all the links are inside of the notes. But if we then look into, this is a drawing, a lot of information, but in essence, it all has the same you saw with the SolarWinds solution. So it has build pipelines, it signs artifacts based on Sigstore. It has the ability to verify images. And one key thing that is different is the admission controller you see at the bottom, which is the policy engine of deciding to release something or not, right? So look at the SBOM that I showed earlier. Have you done all the QA? Is the security scan done? Did not any files get altered in a step that I didn't expect to happen, right? That kind of things. You can all have that captured in policies and then decide based on that if you want to do that. And it's funny because when I started out talking about this, Google had two projects called Grapheus and Cretus, which in essence was the end policy and harvesting of data you saw from both Tekton in case of the OpenShift solution and also from the one from SolarWinds, right? So Grapheus is the database that can consume all the artifacts that you're producing, like, hey, this build has been run, this code has been analyzed, these are the vulnerabilities, that's all being put in. And Cretus is the policy engine. Allows them to decide if you want to deploy stuff on Google Cloud Platform or not. And they've used this already. I think this was like 2019 when they start talking about this. So this is like the right direction. And I think that's really cool that they were able to deal with it. Because if you look at it, there's an RSA talk done by Mark Rusunovich, I think last year, where he talked about securing open source. And he says exactly we need to step up and make sure that the supply chains become more secure by default, because it's a big problem. And as I said, a lot of movement, also a lot of open things, academia still falling into place. But if you can take smaller steps, then we're in a good space. They would ask me, like, can we do the same with Azure? If we run stuff on Azure. Or if we store stuff in Azure in Azure artifacts. There is a policy engine that can, I think it's like open agent based, I believe, that can allow you to do attestations. All the demos you see here, it will just check that if you deploy a container, that it only has port X open before you deploy it. But you can imagine that you can also probably do similar checks, as I said before, like, hey, in case of the software supply chain SBOM, does it contain security scan being done, yes or no, right? You can have the same questioning and then have it as a admission or like policy controller before you decide to release or not. A lot of things, and as I said, there's a lot of open ends, but I think we're heading into the right direction, and there's still a lot to talk about. And in my abstract, I mentioned something about Google SLSA, and I was like in a bit of doubt, like, should I start out with this or should I end with this? Because what I think is good is that Google has started this initiative by saying, like, hey, we have a software levels of supply chain levels of software artifacts, or SLSA, as how they call it, as the acronym, that will identify risks inside your supply chain. And you will see, if you go to their website, there's the model, and you will see like a lot of equivalents of the examples I gave. Because yes, I agree, some of it is based on what they're saying here. But it allows you to have different levels of, not compliancy, but levels of direction. So if you're at SLSA level 2, then your builds are reproducible and you don't rely on any obscure build service. Maybe you have it run on a service like GitHub Actions or Azure Pipelines, whatever, right? Or GitLab, doesn't matter, but that will give you some guarantee. And SLSA is an ongoing thing, but it allows you to show the outside world, saying like, hey, this is my scorecard in relation to supply chain, right? This is, again, a Google product. A scorecard that shows others like, hey, this is the thing, decide for yourself if you want to use me or not, based on it. So, with 5 minutes left, I'm going to conclude. So, If you look at supply chains as a whole, I think the supply chain hacks, it's not a matter of how, it's more a matter of when. They will happen, and it would be really good if you're able to get the information you need to take the right decisions, as I said. If you start out doing a simple like SBOM creation of that dependency tree, that's step one. Then look into the other things that SLSA offers, then do that, right? If you're going to use in Todo and do the attestations by hand, then I'm going to say good luck, because that's a really hard approach. I do love the fact that it works, but it's too complex, I think, for people to use it in a broader fashion. Be aware of what you use inside your supply chains, right? Packages come from everywhere. Know what you pull into your projects. It's almost the same. And working for a security company, I can only say, like, integrate security into your development lifecycle. Important, right? From the start, do threat modeling, decide what the risks are for the apps that you're building, and work out on that. And start on creating on, as I said, simple SBOMs, or look into what SLSA can offer you in moving forward and taking small steps. So with that said, I'm going to show the last slide. So these are the two repos. There's no typo in those repos? No. You can find the app, the web app itself. You can see the GitHub action run. And with all the artifacts, you can download them. As I said, for the whole validation of the in-toto stuff, you need to grab files and combine them. I might do a recording on that one later, or another conference. You can see it. But there is a potential in fixing it. So I think first up, let's see if there's any questions in person in the room, because that's nice. And I'm also going to check the room Slack, as I said in the beginning, just to be sure that I'm not missing out on things. Please share your slides. Yeah, that's what I'm doing here. So that's the one I'm answering right now. Thanks for that, Oleg. Concerning the dependency confusion attack with NPM, can an organization defend itself by making its own NPM scope? I think that's similar to limiting a scope within, let's say, prefix for the NuGet packages. It will probably limit the things that get in, right? So that will reduce the risk. Sindre, I think that answers your question. So I think it's a good idea if you're able to do that. Okay. So with that said, I'm going to be around a while here. I'm going to be on Slack. Drop me a message, or drop me a message on Twitter or my email. And thank you for your time.